which will be covering some basic concepts, database concepts, that we will be diving deeper into as we move forward in the course. Also, giving you a high-level architecture, how a database system typically looks like, and what are the major components you find in most databases. So this is the outline of the items that we will be discussing. So first is, why DBMS? What is the key idea behind it? A very powerful idea that we will see how it influenced the database world and other fields. Then, when we talk about database systems, especially relational database, there is this very important golden standards called ACID properties. We need to start thinking about them. We start to get some idea what they are. And as we move forward in the course, we will dive deeper into them and see how the database, what techniques the database utilizes to achieve those goals or those guarantees. So database, as a database system, it provides you some guarantees. Those guarantees are codified as ACID properties. Then, to achieve these ACID properties, databases typically have some components that help the system achieve those guarantees that are codified in ACID. Finally, since the 70s, almost up to 2000, relational database enjoyed almost a monopoly. Whenever you think database, first thing come to mind, the relational database, something like Oracle or MySQL or SQL Server. But there was a major kind of revolution known as NoSQL. And they said, okay, especially for ACID, not all applications need this ACID guarantees. We can live without them to gain other qualities such as scalability and better performance. And this movement resulted in many other databases that became popular, especially document-oriented databases and graph database. And so in here, I will introduce this movement so you get an idea what this movement is all about, why it was created, what was the result of this movement. And then whenever there is a revolution, what happens? We've seen it all over. There is a counter-revolution, saying, no, SQL or relational is the best. It must be there. ACID are very important. And then this new counter-movement, what's the name of this counter-movement? NewSQL. Says, okay, we know that SQL servers or relational database servers, to deliver these ACID properties, they they pay the cost of scalability and pays the cost of some complexity. Said, okay, we will redesign relational databases with scalability in mind. It's kind of a new generation relational database management systems. They call themselves New SQL. So this new movement, we need to be aware of them. Some of them, they were movements, not some of them. Both these movements resulted in some good outcomes, good products that are now, some of them, widely adopted. Like MongoDB is one of the widely adopted database management system that we really need to be aware of and consider when we design and develop database systems. Define first what is a database and what is a database management system. And then we can discuss why do we need such database management system. So there are some entities that we care about in the real world and we want to store some information about them. So we collect such information in a way, and this information is typically related. So in a database, particular database, you might find database for banner system. It's all the tables that are, and the data managed in that database are somewhat related. So it is a related set of information, of data that we care about in a particular application. Because some of you mentioned table, others mentioned object. Can you see here? Some of you mentioned database store data about objects. Some of them said database is a collection of tables. Okay, very good. So you see here, there's some different terms in the software development world. There are some some guys, they call themselves software developers, and others database developers. Okay, or traditionally or historically, these are two different communities in terms of research and development. So when they developed concepts, they use different terminologies. So in the database world, you find database people talking about entities, talking about tables, okay? In the software development world, you will see people talking about classes and objects, yes? So when if you want to represent some real entity, real world entity that exists in the real world, you want to represent it in your software. When you represent it in a running software, it will be an object. When you develop a software, that object is defined as a class. So just don't get these terms to confuse you, but at the same time, you need to really be careful and have a clear understanding of the differences. So first of all, let me tell you how the story starts. So, the world around us, at the end of the day, in very abstract way, very, very high level, if you want to describe it in a very high level, what is the world around us? Things that are around us. What's a general name that we can give?
Objects.
Objects. Yes? So things that are around us are objects. And these objects, like chair, table, projector, computer, myself, you as a student, this classroom, at the end, what is the high-level abstraction we can, as a general term, we can describe all of these is an object, yes? So the software people, the software engineers, they see the world as objects. And these objects, they have two things. The software people, they have some data about them, about the object, and there is some behavior. Yeah? Or methods, if you want to use the terminology. You see, it's a problem of terminology. So the database, the software engineering people, they see the world as objects, and objects have attributes or properties and methods. So for example, if we take the light or the bulb, let's say, if we want to describe it, you might have, let's say, the manufacturer name, maybe Philips or some other company, the date it was installed, the color, is it white or is it like, let's say, yellow? These are some information about this particular object. And then this object, it can offer some functionality. It has some functions associated with it. You can turn it on or you can turn it off. So as a from software engineering perspective, when you look at your problem domain that you're trying to create an application to automate that particular problem domain, when you try to reflect that domain in your software, you reflect it as objects. And those objects have relationships between them, and those objects interact between each other. This is if you put the software engineering glasses. You will see the world as objects. Object has attributes and methods, and these objects have relationships, yes? And these objects provide functionality to each other. So program at the end, from software engineering perspective, what is a program? A running program. If you look at a program and you basically kind of open the box, what you will see? No, you will see objects. Object 1, object 2, object n. And these objects calling each other, providing services to each other. Okay? So that's basically the idea. But when we develop the software, when we write the code, these objects, we describe them using a class. So those of you coming from software engineering background, when you develop software, you look at your you start from objects because the real world is made up of objects. And then you take objects that you group them and you create a class out of them. For example, you have students, you have Fatima, you have Sarah, you have Suhaila, you have Ali, you have Ahmed. Those are objects. And then you describe them using one definition. This definition, we call it a class. So in your software, you will create a class called students, and you start describing the properties of this class. The properties you care about. The object in the real world might have a very complex set of data about them. We might not care about everything. We only focus on what is relevant for the application we're trying to build. Yeah? So for example, in the context, if we're trying to build something like a banner, so definitely we will have one of the central objects in the whole system is student. Without student, everything will not exist. Okay? So the student is an object, and then when you describe it in your software, you create a class for it. And then you start saying, what are the data items I care about for a student? What do you think? What are the attributes that we care about?
The name.
Student's ID, name, date of birth, yeah? GPA. Sorry? Nationality. Sorry? Username, yes, program they are following. And so, yeah? We might not care about their height because it's not relevant for our application, but we care about the nationality because it's relevant for the fees. Maybe different fees based on the nationality, okay? So what I mean here, we have some real world objects, we abstract them, and we represent them in our software, and we only focus on what we care about in our particular application. This student, they might have a cat. We don't need to describe it in our system. We don't care, okay? But if it is some other application, maybe some application to do with, let's say, hospital management application. We might care if the patient has pets. We need to record that because maybe some medical condition can have connection with that. But for student context or banner, it doesn't care. Whether you have a cat or not, it doesn't care. So we abstract from the real world, we abstract objects, and then for these objects, we try to capture the attributes relevant for the application we're trying to build. Yes? Now, for software developers, they don't stop here. They move on and say for each object, what this object can do, what functionality this object can offer. Okay? So for example, let's say, for a student, they might, for example, register or apply to the university, for example, or they can drop. They might have some functionality associated with them in that particular application. Let me give you maybe another example, much better. Let's say in Banner, we might have a section. You know, courses have sections. A section, what do you think? What attributes we can have in a section?
Section number.
There is a CRN, you know that unique number. There is what else? The course the section is associated with
The time.
label L1, L01, L52, and semester, the time of the lecture, and so on. And this section might have some functionality associated with it. You can go to a section and register in a section, add yourself to a section. You can drop yourself from a section. You can assign a time or change the time. You can change the location where the section is located, will be delivered, which location will be delivered. So what I mean by this, to summarize, the software engineering people, they look at the world as a set of objects. These objects have attributes and methods. Attributes store data about the objects, and methods provide some functionality that the object can do for us. Is clear? This is from software engineering perspective. From database perspective, they have similar, when you put your database glasses from a database engineer or database designer or developer, they can also see the world as objects, yes? But really, they don't call it object. They call it entities, and when they capture those objects, they will represent them as entities and entity types, or they call it also entity set in their diagram. And they don't care about the functional aspects of the entity. They just stop in the data items that we can, the attributes. So when they are doing the modeling, when the database developer do the modeling of a particular system, they also see what are the major objects or entities in my problem domain. I identify them, and then for each entity, I'll go ahead and start listing or enumerating the attributes or columns that I care about for that particular entity. So from database perspective, do we go and look at what functionality this particular object will provide? No, database people, they don't care about that part. So what I want to say, a really database does store, at the end of the day, it does store objects. It's just different terminology. For software engineers, they are really dealing with objects, and they are dealing with both the data that stored in the object and the functionality provided by the object. Now, the database people, they don't use the term object, they use entity, but they are exactly the same. It's just the entity only has the data part. It does not have the functional part. Yes? In fact, when we build a data model, there are many ways to do it. One way, if you are coming from software engineer, if previously you are a software engineer, not too much into database, you can typically, when you design your system, you capture your design in what is known as a class diagram. Okay, so this class diagram captures the major classes in your problem domain, the attributes of each class, and the methods associated with each class, and also the relationship. Yeah. So, for example, I don't want to go into too much details right now, but I have to stop somewhere because I really need to cover other concepts. But just to summarize quickly, the software engineers, they capture their design in a class diagram. Yes, and the database developers, they capture their design typically in what diagram? It's a diagram called ER diagram. There is a lot of similarity. They are almost the same. At the end of the day, both of these, they capture objects in our problem domain, and they capture the attributes that we care about for each of the objects. It's just in here, what do we call this object when we capture them in a class? A class. And what we call those objects when we capture them in our data model? We call them an entity. They are وجهان لعملة واحدة. It's like basically the same thing. It's just in here. We capture a little bit more, because we capture not only the data aspect, we capture the behavioral aspect. In here, we mainly focus on the behavioral, on the data part. Yep, is kind of clear? So to summarize, at the end of the day, a database stores data about related objects. Yeah, we can call them objects, entities, tables. It doesn't matter. These are just different terminologies from different domains. At the end of the day, let's say in Banner, if you are building something similar to Banner, you will find the student class in your software implementation, and you will have student table in your database. And basically, there is a link between the two. Yeah. In fact, in those of you really into advanced software development, there is something called object relational mapping. There are libraries out there where you can link your objects with your tables. Yeah. In fact, if you have classes, you can generate the tables and vice versa. So this is just to highlight further that looking at the problem capturing the design of your problem, whether from database perspective or from software engineering perspective, you will come up. The foundation will be the same, with some differences, of course. So this is a database. It's a collection of related data about certain objects that we care about. There is some historical kind of evolution. So initially, when people start developing software, the program that you write manages its own data. So the program itself, typically using files. So, for example, in Banner, if you want to build a banner before 1970, most likely you will use files to manage the data in Banner. So you will have, for example, student file, you will have a course file, you will have, let's say, a section file, rooms file, instructor file, and so on. Okay? And then you as developer, you write the routines or you write the functions to read and write from these files, to query them, to delete from them, to update them, and so on. Yes? What is the problem with this approach? File-based data management. There are many problems with doing this approach. Nobody does it these days, except if there is simple file, some simple little file that we read and write to. But nobody these days do serious data management using files. Why is that? What's the problem of using files for data management? You as developer, you have to spend the effort and the time to read and write, to join, to filter, and to do all the operations yourself. And guess what? All these efforts, when you do it, if you build another application like Blackboard, and you have other files there, you have to repeat that effort. Of course, you might have some routines that you can import and reuse, but basically, that same effort will be repeated many, many times. Okay? And there are a lot of tricks of improving the speed of querying, improving the speed of managing files that you have to implement in this application and that application and that application and so on. So, and plus there are many challenging problems when you're dealing with data management, such as multiple people reading and writing to the same file at the same time. How you manage this? You have to deal with disk failures. You have to deal with many network errors and so on. Okay, and you are on your own as developer if you use file-based data management. So, what really the database brought along, we took all the data management that was previously embedded in our softwares. And what did we do to all those data management routines and data management functionalities? What did we do to do all of that? All that piece of code to deal with data management that was previously embedded in our programs, what did we do to all of those codes? We kicked them out from our program. You are out. I have nothing to do with you files and data management. It's not my domain of responsibility. I take it out of my system and give it to whom? To the database management system. This is a very powerful idea at the time. So if you look at it deeply, much more deeper, when we use files to manage data, us as developers, we have to worry about how. We have to worry about how do we read from the file, how to query it, how to filter it, how to join the files, and so on. Yeah, we take care of the how. And we take care of a lot of challenges, such as handling failures, handling concurrent access, and so on, handling security, and so many aspects that we need to worry about. And we have to do it, what is known as, we do it in an imperative style. What does it mean, imperative style? Those are important concepts you need to be aware of, because those concepts, as I mentioned, initially appeared in the database, and then other domains borrowed those concepts, including programming and workflow management and business process management. What does it mean here, imperative style of development in terms of data management? Imperative means Yes, you implement the how yourself. You implement the how yourself. Yes. Now, when the database world, when database management systems came, DBMS, database management system came, all this imperative code, we kick it out from our implementation and we gave it became the responsibility of database management system. Yeah. Now, our role as developers, instead of doing the how, instead of doing the imperative coding to read and write data to files, we change from imperative style of development to declarative style of development. What I mean declarative is, as developer, I only need to tell the system what I want, not how to get it. Yeah. Okay. Let me show you this in concrete way, and based on this, I will explain further. Because you really need to understand this concept, very, very powerful concept, and I will explain to you other implications of this in other domains. How many projects we have this semester? 36 projects. Now, me as developer, what did I write here? Is this the what or the how? This is the what. Are you following? This is called declarative programming. This is a major. You cannot imagine how major is this. And to show you how major is this, the guy who really kind of first proposed this idea, he got the Turing Award. It's like the Turing Award is like the, what they call it in the literature and physics. What's the equivalent? I forgot the name. Nobel Prize. Yeah. These days, what is the Turing Award? What is the amount of this award? Do you know the amount? $1 million these days. Yeah. So it's very prestigious. So the guy that first kind of brought this idea of having things to be declarative rather than imperative, where developers do the what rather than the how, is very profound idea. It shifted the whole thing, the way we develop software. You see how database is really important and different. Don't see it on the surface. It's a very deep change that gets introduced when you use database. So you move from manipulating the files yourself to what? To the how and imperative style to a declarative style. And basically what happens here, what you need to do, you just need to express what you want and leave the how to whom? To the database management system. Yes? Now, the database management system, you are on a safe hand. In fact, I think 5 or 6, if you go to Turing Award in Wikipedia, let me see. This is the award. This is the reward amount, $1 million. If we go there, these are some database, just database. This guy, outstanding contribution to database technology. This is the guy I told you, 81, Edgar Code. This is the guy that really kind of proposed this idea and had some mathematical foundation behind it. And many other database people got this award. Yep. This is the latest, 2014. Okay, so what I mean here, the introduction of a database management system shifted the responsibility of managing data from the developer responsibility to database management responsibility. Okay, now let me show you. Let me see here. Okay, here. So let me show you. So database when I run this query, the database engine has a query processing component. This query processing component translated this high-level query language to a physical, what we call query execution plan. In the world of file-based management system, the whole responsibility of managing the data lies on the developer. They are the poor guys. They have to create the files. They have to fill the files, query them, join when there is a complex query, delete, take care of errors, take care of concurrent access to the files, take care of security, and so on. Yes? Now, once we bring in a database management system, we kick out this responsibility and this code, all of it, we outsource it, we push it away from our application, and we give it to a database management system. In fact, the database management system, when we design our system, is an external entity. It's outside our system. Database management system is not part of our system. It's outside. You go and either use an open source like MySQL, or you go commercial. If you have money, you go for Oracle or SQL Server or something. Yeah, it's something outside your system. Now, your responsibility. What is your responsibility when you use a database management system? You have two roles, two major responsibilities you need to do.
Express what you want.
Express what you want. Thank you very much. This is basically you need to be able to write queries. And to do this, what you need to do, what you need to learn,
The terms of the query.
which is
And you need to fix
SQL. You need to learn a language, a new language. This is a new responsibility. You need to learn a query language. One of the famous query languages is the SQL. Of course, the revolution, you remember the NoSQL I just told you before? Said, no, SQL is not, it shouldn't be the dominant monopoly over database management and querying. But still, it is the most important skill. You cannot call yourself a database developer if you're not mastering SQL. Very critical language to know, because that's how you will express what you want from your database. What else you need to do as developer?
create the tables and
Very good.
the relations.
Excellent. So what is this task that you do?
Creating the relation.
No, as a task. Modeling. Thank you very much. You basically need to create database model. You see the responsibilities has shifted completely. The life of developers before 70s and after 70s is very different. Yeah? So these are the new responsibilities. So for you to use a database management system, what do you need to learn as a developer? Two major skills, new major skills. How to design a database model, which we will study in the next session, and how to write queries, efficient queries, okay? A good way of writing queries. And if you want to write good queries, it will help you if you know how the database works. You see how I'm trying to connect the components of the course? So yes, you can learn the language. It's important to learn the language. And also when you're writing, there are many ways of writing your queries. If you are aware of how the query executes, you can do much better job. It's clear? But for now, as a beginner developer, database developer, these are the two skills. If you don't have these two skills, you cannot call yourself a database developer. Simple. Yes? Now, this database model, how do we build it?
From the objects that we have.
From the objects. No, what is the process? How do we start? No, just we dream about these tables. We have a nap and then we dream about them.
Diagram.
Diagram is a tool. Analysis. Basically, you go and talk to people. You find out their requirements, why they are building this database, what they are trying to achieve, what's the problem they are trying to address. And then depend on your background. If you come from software engineering background, you can put your object-oriented glasses and try to identify objects from the requirements that you collect from your users, from your business users. Yeah? And then you capture that in a class diagram. And in the class diagram, it will have entity classes, and those entity classes will become tables. We will see this in the next session. Or if you are coming from database world, you are a database developer, you put your entity relationship model glasses, and then you try to identify the entities and the relationships between them. And that is what is known as a conceptual model. And then you revisit your conceptual model, and you go to each entity and say, what are the attributes we care about for this particular entity? And so on. This is a process you go through to define and refine and improve your model until you are happy with it. Then what you do with this model? Implement it. How do you implement this model?
Creating tables.
Creating tables. How you will get those models? Sorry?
Using the manipulating language like create.
That's one way of doing it. One way of doing this database model. Typically, the most common what comes out from this exercise that we will go through in the next session is a very important diagram called ERD, Entity Relationship Diagram. What this diagram captures?
The entities and relationships.
Entities, which are the objects we care about, the relationships between them, and the attributes of each entity. Yeah? Now, sorry? The attributes or fields. There are many terms, but whatever term you are comfortable with. Now, if you did this diagram using pen and paper, then now when it comes to creating the database in your database management system, you will pay the price. You have to use SQL to translate your diagram into SQL statements to tell the database, go ahead and create the table. Go ahead and create this other table. Link these two tables, and so on. Just to give you a glimpse, those of you not familiar with this, just to give you a glimpse how this looks like. So if I go here and script the create to a new query editor, this is how the create table looks like. Hopefully it will come. It will say create table. These are the attributes, the name of each attribute, and these are the data type of each attribute. And there is something called constraints. I want this column to be unique. I want this column not to have nulls. I want this column to be always greater than 0. You can put some constraints when you define your table. You can see here the table. You can see here my nice names, meaningful and descriptive names of attributes, descriptive names of tables. Nobody called me in the last 10 years, asked me, can you please explain what this table does or what does it store? Because everything is self-describing and meaningful. Yeah? Okay, that's basically, so if you create your model using pen and paper or Word, bad luck. Every entity you have identified, what you need to do? Spend your night typing everything again. If you use some smart tool like Visual Paradigm or many other tools, the good news is you define your ER diagram graphically, and then when you want to create the database and the tables, what you need to do? Click and say generate SQL, and you choose which database you want. MySQL, Oracle, SQL Server. They have some slight differences here and there, okay? But the tool knows how to generate the right SQL for the right database. It's clear how do we create the model? Yes? The model, we don't see it in the dream and then wake up and write the model. We go to the ground, talk to the people, collect the requirements, make sense of them. It's back and forth, couple of days or weeks, depend on the complexity of the system. and then you have some ER diagram, and you validate it. Go back to your users and say, this is what you mean, and clarify and so on. And you will be surprised. They will be impressed. Many things they didn't even think of, you managed to capture. SQL as a language is a standard language. All database management system implement this language. But every database management system try to offer something extra, some extra features, some extra capabilities. And that's what makes it not so standard. So there are some SQL is a standard language. You can go to the web and look up SQL standard. You will see all the statements that come in SQL. And even the standard has some versions. I think this is SQL 86 and so on. There is an organization taking care of this SQL language, and database people take this standard and implement it. But they add their own spices. And basically, you as developer, you need to be aware of SQL in general and some features that are specific to each platform. Yeah, but in terms of data model, it's almost the same. Yeah. So, for example, in SQL Server, the variable length string attribute is known as varchar. Maybe in Oracle they will call it vchar or not sure. There is some varchar too. Yeah, you will get some different name. Okay. For example, here constraint primary key, you might have slightly different syntax, but the concept is the same. Yeah, and of course some extra features. For example, in SQL Server there is something called identity column. What does that mean? Project ID is an identity column.
So it's unique.
Not only unique,
It's defined that.
auto-generated, auto-incremented. When I insert a new project, what will be the ID of that project? The last used ID plus 1. So in SQL Server, we use this identity. I come to the column and say identity. In Oracle, if you put identity, it will not know what you're talking about. They use, I think, something called sequence. And you attach a sequence to a column, if I remember. Yes? Use something. Yeah, so something a little bit different than this. You get what I mean, yes? That's why in the ER diagram, or that's why in database design we have 3 levels of design. What are these 3 levels? When you do your design, you start with the conceptual diagram. What is a conceptual diagram? It just has the entities and the relations. Because you need to go slowly from high level to go down deep into the details. So conceptual diagram is similar to what I showed you when I described GitHub. Remember when I described GitHub? That is a conceptual data diagram. Then the next one is, it's called a logical diagram. In the logical diagram, what you do? You add attributes. You might also, relationship, you identified some of them in the conceptual. Yeah? You add attributes. You might add data types of attributes. You might even identify primary keys and so on. In the physical, you have to cater for the target database. So for example, you might say this column, because I'm targeting SQL Server, this column will be the identity column. So this is, you come in now to the physical, the last part. Basically, you are doing a process of refinement from conceptual to logical and then physical. But in practice, you just do the conceptual and logical is you do it in one go, especially when you become more and more we're having more and more experience. You identify the entities and you start also identifying some of the attributes. No. You collapse the logical and the conceptual and the logical in one step. Or you can do it in 2 steps. It's up to you. Now, the physical, you basically, in practice, you go to your logical design, you generate the SQL. and you take the SQL and refine it a little bit more if needed, yeah, in practice. So to summarize, because we will visit this concept later on, if you use a database management system, you are relieved from the how, and your responsibility becomes totally different. What is your responsibility as developer when you use a database management system? Two responsibilities. No, first is the data model and the query language. That's it. You don't care where are the files, how the files are managed, whether one file or 10,000 files. You don't care. It's a black box for you. You don't need to know anything else. In fact, you can come to a database that you never saw before. For you to interact with it, what you need to do? What you need to know? Language, you already learned it. You learned it once. Queries, all you need to know is data model or database model. Also, what's another name for the database model? The database schema. Okay, so don't let these terms confuse you. Model, schema, lots of schema, okay? ER diagram is just a tool to visualize the schema. So don't confuse the terminology. But model and schema is the same. The good news, even if you come to a database you never saw before, database can describe itself. That's another advantage of database. If you have files, you lose that feature. You cannot, file does not describe itself. You have to open it. And hopefully it just have few records for you to make sense. If you go and open a file that has millions of records, good luck when it opens for you, let alone explore what's in it. But in database, no. Database is very transparent. You can come to it, here it is, and you can see here, I see all my tables, and I can see all the columns, and all the keys, and everything is transparent. Now, what I mean is database already, when you define the schema, database stores the schema and stores the data. And anytime you can extract this model. So all you need is here. You know this is the power of database. Once you model your database and you spend some time crafting this model, using some principles and some guidelines that we will cover next week, then your imagination is the limit. Believe me, I worked for many years in some company. Every day, these managers, they are so creative. Every time they have some new query, some new things that they want to know. And all we do, try to understand what they want and craft SQL statement. That's it. Submit it to the database, and in half an hour, 1 hour, you get what you want. Yeah? This is called ad hoc queries. This is the power of SQL. Ad hoc query means you take a nap, you wake up with some question, and you go and write the SQL statement to get it. Yes? So for example, in this database, you remember this little example I showed you? My imagination here is the limit. Give me the Qatari student, how many Qatari students are taking senior project? Yes, boom. In few minutes I can craft it. Give me the ones that have the GPA is 3 and above, and so on. You know what I mean. Give me the projects that have industrial partner. Give me the projects that are CE, projects that are CS, and you name it. Yeah. Even if you never saw this database, I'm sure if the model is nicely crafted, the columns and the entities are meaningful and descriptive, and you have some knowledge of SQL, you can craft query. To summarize, these are the responsibilities of us as developers building the model. You need to learn how to build the model. And writing the right queries, you need to learn how to write SQL. Those are two critical skills to know as developer. Okay, moving on. And the power of database is that behind it is at least 50 years of research and development. 50 years. Like what you see here, this little, this diagram here is query plan. What the query plan means It translates your high-level SQL into file operations. File operations are still there. There's no magic. The data is not stored on some kind of cloud or somewhere, some kind of magical units. Still, files are still there. And reading and writing to files is still there. It's just done in a much, much smarter way, yeah, by the database. So in here, it will tell each step what we need, which file to read, how to read it, what are the steps, how to connect the intermediate results into multiple steps. This is the imperative. So you go for declarative, and who generates the imperative code? The database. And behind this imperative code, lots of smart algorithms. We will see some of them. Yeah, very impressive. Some tables could have millions, even in this small laptop, millions of records. Query results in no time, very fast, thanks to the algorithms behind it. Even if you try to do it yourself, you will not achieve that level of speed. Because as I said, because this area it's a very lucrative business. Database management. Database is the most essential component in the whole organization. If database fails or corrupted, or it's a major problem. Imagine some organization without its database. Khalas, they will go bankrupt. They will disappear from existence. So it's critical. So behind it, like Microsoft, Oracle, all these big, Google, all these big organizations and institutions, MIT and Qatar University and all the organizations are working heavily on this domain. Always improvements, always new ways of doing things. So behind you basically, as a database, every time you let's say upgrade the database or upgrade your hardware, even you upgrade your hardware, your database will take advantage of that new hardware to even speed up the execution of your queries automatically. You don't need to worry about anything. Yeah. Okay, moving on. So this is the summary of the power of database. Us as developers or as an application, all I do, I write my query in a very high-level language, specifying what I want. The database management system takes my query, analyzes it, and generates from it an execution plan. And this execution plan, it takes into account the current conditions. It takes even into account how much memory the machine has. It takes into account the presence or the absence of indexes. Don't worry, indexes will come later. It takes into account a lot of things, how the database is organized, how many records you have in the database, yeah, whether to use the index or to use a full table scan. All of these decisions, the database will generate the optimal plan, the one that will be super fast. Okay, and then it takes that plan and run it. Not only this, this is one of the major responsibilities of the database. The other thing is to keep your database safe and correct, even if there are failures, and even if there are concurrent updates. These are major challenges. If you try to do it yourself using files, good luck. When you have thousands of concurrent users trying to read and write to the same data item, and you don't want any conflicts or lost updates or somebody overwriting other people overriding each other's updates. Okay, so I think these slides explain what I already explained. Let me now quickly jump to this, just to summarize the whole idea. So when you add a database system into your architecture, into your solution architecture, the responsibility of the developer shifts to these two responsibilities and two skills. Building a data model, you need to learn how to do it, and you need to learn how to refine it, and if you don't have the right data model, your database cannot help you. You have to have the right data model, and you have to have a nicely crafted query. good, efficient query, efficiently written query. Okay. Once you do this, database will relieve you from the physical data organization. You don't need to worry how the database is stored, which files, how it is distributed. In fact, some databases might store your data in multiple servers. If your database becomes too big or you have too many users for one server to handle, some databases, not relational, non-relational, they can spread your data into multiple servers without your intervention. And also, all magically, you give the query, database will work out what to do, get the result, and give it to you. Yeah. Okay. And all this, this what we know. This is the powerful idea that database brought. It's known as the physical data independence. You no longer need to worry about how the data is physically stored, how the data is physically managed. It's not your responsibility anymore. It's the responsibility of the database management system. And this guy, Edgar Frank Code, is the one that really kind of invented or put the seeds of this idea. Okay. So let me now jump quickly to this other aspect of database. Another critical aspect of a database management system is these guarantees that the database gives you. Database gives you some guarantees that your database will be consistent or will be correct, even if there are failures or even if there are errors. Yeah? And these guarantees, as I tried to explain earlier, are kind of summarized in this term known as ACID. So let's quickly go through this, although, of course, throughout the course, we will dive in deeper into each one and see how the database delivers each of those. So far, if you want to create software and call it a database management system, okay, if you have the courage to call it a database management system, what this software needs to have? So far, what we have discussed so far. You want to create, let's say you want to create a new database management system. Yeah? So far, according to what we discussed.
Interpreter to the language of the queries.
Okay, very good, yes. So you have an interpreter of the query and somehow from that query to generate an execution plan. Yeah? And another one is to take that execution plan and execute it. Yes? That's one part. So basically, at the end of the day, some kind of query engine that take a high-level SQL statement and translate it into an executable program to generate the answers that you expect. That's one component. Okay. The other one, for your system to qualify as a database management system, it needs to deliver these 4 guarantees, which are named as, first A stands for atomicity, consistency, isolation, and durability. These 4 very challenging guarantees that you need to deliver to your users. Otherwise, don't call whatever you are developing as a database management system. So it's not only the query processing, which is challenging enough, not only the query processing, also your database management system needs to give these guarantees, these ACID property guarantees. Okay, so let's just try to understand these ACID property guarantees. Let's start with atomicity. What this atomicity means? What does it mean? Atomicity means if your implementation requires multi-steps. Are you following? Let me give you an example. By the way, these concepts, when you learn them, you really need to learn them and associate them with the example. With the time, if you forget the concept, you can reverse engineer it from the example. Yeah? So the famous example here is transfer, bank transfer. Imagine you are QNB, yeah? And Sarah wants to transfer to Ahmed 500 riyal. This involves how many operations for the bank to do this? How many physical database operations to be done to achieve this goal of operations?
Take the money from
Yes.
deposit and
Let's use more sophisticated terms. The accounting terms. What do we need to do? We need to debit one account. Debit means take the money from one account, debit the account by $500, 500 riyal, and then credit. We need to use the terminology when you are talking with the domain experts, with the domain. Of course, you learn quickly the domain. Don't use some other terms. You are talking to Q&B bankers. Don't use take the money from this account, put the money in the other account. They will be laughing at you. No, you say, no, you credit this account and then you debit the other one. Are you following? So, credit means, in a simple term, all I do, I will say here, read A. This is account A, which means read the balance of A. This is basically, what is this? This is the debit part. Yes? Read A. What I will do with A? A equal A minus 500. And then what I will do with A? Write A. By the way, in high-level abstraction, database really knows two operations. Read and write. That's it. I read. I do this update. Maybe I do it in my program. I change this value. And then what I'll do? Write the A. You happy? So this part we are debiting this account. We took the money from the account. Yes? And then the other account, what we'll do with the other account? Read B, and then B plus equal 500, and then write B. This part is credit. Okay, so to keep both owners of both accounts with a happy day, happy face, what should happen? Both should happen. Okay. Now imagine you did this part and the system crashed and you didn't do this part. What happened? The bank. Who is happy? The bank. The bank is happy because the 500 was taken but not given to anyone. Yeah. Now, in a healthy database, you need to really do these two steps, all or nothing. Very critical concept. This is called transaction. A transaction is a multi-step operations that will change the state of the database. You don't want partial updates. Partial update is undesirable. You don't want that state. You don't want to fall into that state. You always want to do in multi-step all or nothing. So if something happened here, some error in the program or some crash or somebody unplugged the power from the server, whatever happens, the database gives you a guarantee. It can even go to the court and sign for your paper or make a qasam or whatever you want. It gives you 100% guarantee that this scenario will never happen. Yes? It's very powerful guarantee called atomicity. Now, in terms of implementation, all you need to do, let me try to show you just how it looks. Hopefully I have some small example. Let me see. Recent files. I will let you go shortly, but just let me show you. All you do something like this. You do something similar to this. You just say, begin a transaction. Begin transaction. Try to update. If anything goes wrong, whatever the reason might be, power failure, disk crash, disk full, whatever it might, some bug in my code, If something goes wrong, I catch that, and then what I will do? Roll back. What do I mean by roll back? Undo the changes. So I don't fall into partial update. This is a very powerful guarantee. And the database used some techniques to achieve this. And we will see these techniques, how the database achieves this. Yeah. Same thing for, because I need to let you go, but just to give you a glimpse. So A for atomicity, consistency. What is consistency?
So the results is consistent.
The same, whoever is
Good
running
for
the
the
query is
query.
good for all the stuff.
So basically, database will always keep happy faces for all the parties involved. Okay, it does this by the mechanism used to achieve A and I and D. Not only this, you can put some checks into the database. So for what I mean by checks, you see here when I create the table, I can say balance. What is the data type of balance? Money. And here I put what is known as a constraint. Balance, what the constraint says here? Balance cannot be less than 0. Database will employ security guide there. If any transaction that you try to run violate this, what happens to that transaction? An exception will be thrown, and that transaction will be aborted, will be rolled back. Why was it rolled back? Because it violated one of the constraints. So you as developer, you can explicitly and declaratively put some constraints and some rules, and then database will enforce those rules. For example, an order, can you imagine an order getting created without a customer? Or an order created for a product that doesn't exist? These are called the referential integrity constraints. You can define these constraints, database will not allow this to happen. This is what it means by consistency. Yes? Can you imagine you find some course with a grade or some transcript, there is no student associated with it. Or somebody taking a course suddenly appeared in transcript and this course doesn't even exist. So database can enforce this, can make sure can make sure database stay consistent, and it's by checking these constraints. Lastly, atomicity, consistency, isolation. What is isolation? Isolation? Isolation is basically doing concurrent access to the database. Database guarantees, although there are multiple users reading and writing maybe to the same record, it makes sure that as if these users that are updating the same record, as if they are doing it in a sequential way, rather than in parallel, rather than concurrently. So I will explain this, of course, in much more deeper as we move forward. So basically, it makes sure that my changes are not overwritten by yours accidentally. Yeah. Through examples, of course, this will become clear. And the last one is durability. What durability means? If the transaction commits, if the transaction finish, database gives you 100% guarantee your change will not be lost. What I mean by this, because database, remember, it has a trade-off. Database has to be fast and has to provide all these guarantees. Yes? So to be fast, database sometimes don't write immediately to disk. It keeps the changes in memory. It doesn't write them immediately to disk. But at the same time, it gives you guarantees if something goes wrong and the server switch off, even what is in memory will not be lost. So database use some mechanism to do this. Yeah. Believe me, that's why I told you a lot of smartness embedded in databases worth studying, because it opens your eyes to other very smart tricks that can be useful in other contexts. That's why it is important to learn them. Not only this, when you learn them and understand them, you are in better position to create better models and better queries. I hope it's clear, somewhat. Of course, whatever I kind of mentioned now we will go deeper in each of those aspects, answering the what and the how. Yes, please.
I just want the word of E.
D, durability. 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 No. Durable. Okay. Durability. Here. So basically, here it is. Here it is. Here it is. Yeah. Durability. That your change is permanent. Yeah. Even if once the database is, once the transaction is finished, don't worry. Your change is taken care of, even if the power is lost immediately after the transaction is committed. You will understand this more as we go deeper. You will see why this is important. And I'm just giving you a hint now that database does not, when you do some update to some records, it does not go and update the table physically in the files immediately. It does that at a later stage for performance reasons. But at the same time, it is obliged to give you this guarantee of durability. You get the idea? So these guarantees is just a way of describing them, and we will see more details what they really mean and how, more importantly, how the database achieves this through some smart algorithms and techniques.